I have mentioned that a particle of a mass, suppose 2 kg, which starts from rest, and that is possible, though it is initially at rest, and even then if it can starts moving, that is possible due to the constant force of 4 Newton that acts on it for 2 seconds. So the given force of 4 Newton acts on the particle for 2 seconds, and after that, after t equal to 2 seconds, this applied force is withdrawn. That means after 2 seconds, no force is available on the mass. But the displacement has been asked for 6 seconds. That means during the first 2 seconds of the journey, there was a force on the mass, but during the last 4 seconds, because if it is a discussion of 6 seconds, so during the last 4 seconds of the journey is without any force on the mass, isn't it? So what do you think that what will be the characteristics? What will be the characteristics regarding the motion of the particle even after the force is withdrawn? Think about practically. Suppose sometimes it happens in a school, to do fun, isn't it? Sometimes don't you do that? You start pushing on your friend for some distance, and then you start, you withdraw yourself, you stop applying force. Does this mean that the moment when you stop applying force, does it means that your friend immediately comes to rest at that point? Or with that effort what you have applied on him or her, due to that effort he keeps on moving for some more distance even after withdrawing the force? Yes or no? So that means here also the same thing, though it starts from rest, so definitely it will be the force that will make it possible to move during the first 2 seconds, but that does not mean that it won't move in the next 4 seconds once the force is withdrawn. What happens when some force is applied on a block? What happens when some force is applied on any block of any mass? Force brings acceleration. So that means if it is said that force is working on the mass for the first 2 seconds, if it is said that force of magnitude 4 Newton is applied on the mass for the first 2 seconds, that means due to the force on the mass, the acceleration will be produced. So that acceleration will act on the mass for the first 2 seconds. Withdrawing force means there will be no acceleration from t equal to 2 to t equal to 6 seconds. Got it? So what happens when there is no acceleration acts on a body? If 4 Newton force, suppose if I consider this is a mass placed at position A, this is t equal to 0 second instant, initial velocity of the mass is 0, but some force F, that is 4 Newton applied on it. As a result of it, it will gain some acceleration, yes or no? What is how do we calculate the value of acceleration produced on a mass? Concept of writing acceleration is, once force is known, you can write down it is force by mass. The force that causes that acceleration, if that is known to you, then you can calculate that acceleration dividing the force by the mass. F equals to ma, or in other words, A can be written F by m. So F is 4 Newton, mass is 2 kg. So the acceleration will be 2 meter per second square. Yes or no? The acceleration that can be produced, it can be written as 2 meter per second square. So it will be the 2 meter per second square acceleration produced. Are you getting me? So due to this acceleration of 2 meter per second square, it will continue moving to another position which is the instant of 2 seconds. Right. So what do you think that though particles started from rest, but will there be any velocity achieved by the particle after traveling 2 seconds with constant acceleration? It must gain some velocity. So that velocity will help. The velocity achieved by the mass at the position of B, which is the instant of 2 seconds, that will definitely help the mass to move further for the next 4 seconds. So first calculate that velocity, and that will help you to know how far it will move in the next 4 seconds. Provided when it is said that the particle is beginning from t equal to 0 with the initial velocity 0 under the acceleration, what we have calculated it as 2 meter per second square. Can I write down for A to B, for the motion for A to B, since it is accelerated motion, right? A to B is a accelerated motion. So did I say under a constant acceleration we can apply the basic formula V is equal to U plus AT? Right. So if I use velocity at the final point B, that is equal to velocity at the initial point A plus acceleration of the journey into time taken of the journey. V is equal to, this is as per the format, V is equal to U plus AT. U means velocity at the initial position instant, and V is the velocity at the final instant of that accelerated journey. So that velocity at B can be known by using U at A0 plus acceleration 2 into time taken is also 2. So that means that velocity will be just 4 meter per second. Yes or no? The velocity is just 4 meter per second. So here I can understand that velocity achieved by the particle will be straightway 4 meter per second at t equal to 2 seconds. So this journey continued with this acceleration, but that acceleration will be found to be 0. Acceleration becomes 0 for which instant? T equal to 2 seconds to till suppose the position C of the journey, which is the journey at 6 seconds, that is T2 to 6 seconds, that is for the duration of this 4 seconds. This 4 second interval will be continued with the velocity of 4 meter per second. Are you understanding me or not? It will be continued with 4 meter per second. Why it will maintain that velocity? Because now from B to C, you can understand it is in this way, the acceleration switch is off. Okay, accelerating factor is disappearing in this from the situation. So the moment when force will be withdrawn, that means it is the acceleration that is not working further for the another time of journey. As I have taken the discussion up to 6 seconds, so that means from B to C, that I can write down from B to C. From B to C, right, motion will be continued. Motion will be continued with constant velocity, right? The motion will be continued with constant velocity. This time particle will continue the motion with constant velocity. Are you getting me or not? And that velocity will be definitely velocity of this 4 meter per second what we have calculated at the position B, which was the instant of t equal to 2 seconds. So that means this B to C, this displacement, I can write down it is the velocity into time of journey. So velocity value will be 4, time of journey is 4. So it will be 16 meters. So B to C will be 16 meter. The particle will be traveling in the last 4 seconds. And A to B, that is AB, that you can calculate as UT plus half AT square. UT plus half AT square. Can you tell me for calculating A to B distance traveled, AB, what will be the value of u? You need to substitute here. So I have mentioned it in the diagram also with these all details. Particle is starting from rest, means it is starting with zero velocity, and I am calculating A to B, means from this point to this point. A to B, this displacement. To calculate A to B, whenever you will calculate a displacement of a journey, provided if it is performing under acceleration, then you need to take care of, that is, u will be the velocity to be taken. The value of u means velocity at the starting position of that accelerated journey. So A to B is the accelerated journey, so starting position is A, and where velocity value is given 0. So 0 into it is a 2-second journey. So 0 into 2 plus half into acceleration value of the journey, we got it 2, and that into 2 square. So finally A to B, this calculation will come just 4 meter. Yes or no? So overall displacement, then we were supposed to know the total displacement, right? We were supposed to know the total displacement. So here I can write down, therefore I can write down, therefore total displacement in 6 seconds, total displacement in 6 seconds, that is 4 plus 16, 20 meter. Yes or no? During the first 2 seconds, it covered only 4 meter, and in the last 4 seconds, it covered 16 meter.